Hello everyone, in this tutorial, I'll show you how to sync multiple leaflet maps in R to compare different spatial datasets. For example, NDVI, precipitation, soil texture, and land surface temperature. This method is useful for analyzing spatial relationships in environmental studies. Let's dive in. First, let's load the necessary R libraries. These include Leaflet for mapping, Leaflet.extras for extending Leaflet's features, Terra for raster processing, and Leafsync for syncing maps. The next step is to load our sample raster datasets using the Terra package, NDVI for vegetation, precipitation for rainfall, MODIS LST for land surface temperature, and soil texture for land properties. Now, we'll create interactive leaflet maps for each dataset. Let's start with NDVI. We will begin by downsampling our NDVI raster. This step ensures that the raster adheres to Leaflet's display limitations by reducing the number of pixels, making it more efficient for visualization. We will then create our custom NDVI visualization palette. Next, we will visualize our downsampled NDVI raster using Leaflet. We start by initializing a leaflet map and adding a base layer from Esris World Imagery, which provides high-resolution satellite imagery. Then, we overlay the NDVI raster using the addRasterImage function, applying the custom color palette we defined earlier. We set the opacity to 0.8 to ensure visibility without completely covering the base map. To improve user interaction, we add a title control at the top right corner, labeling the layer as NDVI. Next, we include a layer control to allow toggling between different map layers. In this case, we have a base map and an NDVI overlay, making it easy to switch views. To enhance usability, we add a search function, enabling users to find specific locations using OpenStreetMap's search feature. Finally, we include a reset zoom button, allowing users to quickly return to the default view, centered at latitude 0 and longitude 37, with a zoom level of 6. Now, let's render the map. Next, we will visualize the precipitation data using Leaflet. Like before, we first downsample the raster to optimize its display. For styling, we define a color palette that ranges from light blue to deep blue, representing varying levels of precipitation. We then create the leaflet map using OpenTopoMap as the base layer. You can always play around with the base layers of your liking. The precipitation raster is added with full opacity to make the variations in rainfall intensity more visible. A title control is placed at the top right to label the map, and a layer control allows toggling the precipitation layer on or off. Lastly, we add a reset zoom button to help users quickly return to the default view. Now, let's display the precipitation map. Let's move on to land surface temperature, LST. This dataset has a higher resolution, so we apply a downsampling factor of 4 to optimize performance in Leaflet. For visualization, we use the Inferno color palette, which ranges from dark purples to bright yellows, effectively highlighting temperature variations. The base map here is OpenStreetMap, and we overlay the LST raster with 90% opacity to ensure clarity. We also include a title control, a layer toggle option, and a reset zoom button for better user interaction. With that, our land surface temperature map is ready. Finally, let's visualize soil texture. Since soil categories are discrete, we use the model function while downsampling to preserve the most common soil type in each area. We then define a lookup table that assigns specific colors to different soil texture classes, ensuring a clear and meaningful representation. For the map, we overlay the soil texture raster on a dark-themed CatoDB base map, which enhances contrast. The legend and controls allow users to toggle layers, and as with our other maps, we include a reset zoom button for easy navigation. With that, our soil texture map is ready. We synchronize all 4 maps using the Leafsync package. This ensures that when we zoom, pan, or move one map, all the others adjust accordingly. We use Leafsync syncing M1, M2, M3, M4. Ncol=4 arranges the maps in a single row. You can play with the arrangement however you want and also sync the maps as per your interests. This side-by-side layout allows for easy comparison of NDVI, precipitation, land surface temperature, and soil texture. With this, our interactive multi-theme synced map is complete. For further interactivity, you can export the leaflet map as an HTML file to share or embed it elsewhere. Alternatively, you can open it in a new window, where it will be displayed on a localhost server in your preferred browser for a seamless viewing experience. Thank you for watching. Feel free to leave a comment or question in the comment section.